Hi, this is Bill, the Techno Gypsy, coming to you from the Technog Command Post. In this video, I'm going to discuss portable solar power systems and solutions. This will range from smaller systems that support one or two operators up to a larger system, like the one here behind me, designed to support a large group of people for an extended period. On the smaller end, I'm going to show you the portable solar power system I carry in my Radio Go bag. This system is comprised of a Mercury 27-watt portable and foldable solar battery charger coupled with a Instapark lithium-ion battery pack. The Mercury 27 is a light and compact USB solar charging system that easily fits in a messenger bag or backpack. It has 4 monocrystalline solar panels totaling 27 watts that folds up into a pack about the same size as a magazine. Folded, it is 11.5 by 8 by 2 inches and weighs 2 pounds 8 ounces. It comes with dual USB ports providing up to 3 amps for charging your cell phone, iPhone, tablet computer, iPad, MP3 player, USB battery power packs, or any other USB compatible mobile device. In addition to USB charging, it also has a DC output for charging 12-volt batteries. The charging connector is compatible with most portable 12-volt battery packs such as Instapark, Duracell Power Pack series, and Wagon Power Dome series. No additional adapter or voltage regulator is needed. The Instapark MP3450E-60 battery pack is comprised of a MP3450 and an MP3460 lithium-ion battery. This combination provides up to 27,000 milliamp hours, or 27 amp hours to the rest of us, of usable power. It can simultaneously charge 2 devices, one 5-volt USB and the other voltage selectable at either 8.4, 12, 16, or 19 volts. It is a great option for extending the operating life of your notebook, PDA, digital camera, cell phone, or other portable electronic devices between charges. It hooks up very easily to the Mercury 27-watt solar charging pack and allows you to recharge the Instapark battery at any time while in the field. Now that we've looked at the smaller end, let's take a look at this bad boy. This is the power control board for the system. I will be going outside later in this video to show you the complete system, set up and operating with a 12-volt deep cycle battery. But first, let's take a closer look at the power control board. The external solar panels are connected to a Renogy Wanderer 30-amp solar charge controller using Anderson power pole connectors. The Wanderer is a 30-amp 4-stage pulse width modulated charge controller. The 4 stages are bulk, boost, float, and equalization. It can support sealed, gel, and flooded battery technologies. The charge controller connects to a 12-volt automotive deep cycle battery. The battery in turn connects to a PowerTech PS1004 Pure Sine inverter. This inverter is rated for 3,000 watts continuous with a surge capacity of 6,000 watts. It provides clean sine wave power at 120 volts AC. The battery is also connected to a MFJ 4416B super battery booster. The newer version of this product is the MFJ 4416C. This provides a steady 13.8 volt output at up to 25 amps for radios and other Anderson power pole equipped devices. The MFJ 4416B can operate with an input voltage as low as 9 volts and still provide a steady output of 13.8 volts. This ensures that your radios will not lose the ability to transmit as the battery voltage drops below the required operating threshold. Check out my prior video, Improving Field Digital Mode Operation, for an explanation of the required operating voltage of a transceiver and what happens when you drop below that voltage. The output of the MFJ4416B is connected to a RigRunner 4005 distribution box. This uses Anderson power pole connectors for powering your radios and other such things as the water filtration system shown in my clean water video. The MFJ4416B is also connected to a MFJ4416BRC remote control head. This head allows you to monitor the input battery voltage and the battery booster output voltage. It also functions as a power switch and lets you turn the battery alert on and off. It includes LED indicators for boosting and low power. It connects to the MFJ4416B using a standard Cat5 cable. The overall performance of the system is displayed on the Bayrite LCD digital panel meter. This meter shows the voltage being generated by the solar panels, the amount of charge current in amps going to the deep cycle battery, the overall power in watts being produced by the solar panels, and the total energy generated in watt-hours. The system uses two external 100-watt high-efficiency Renogy monocrystalline solar panels to provide power. These are well-built, fairly lightweight aluminum panels that I have modified for transportability. I connected the solar panels together using 3 hinges. This allows the solar panels to be folded up for transport. It also provides protection for the active side of each panel. There are 3 standard 3 by 2 inch hinges I picked up at a local hardware store. Just be careful to ensure that the attachment bolt holes are drilled into the aluminum frame and do not damage the solar panel. The toughest problem I had was finding a way to securely lock the 2 panels together for safe transport. I came up with the idea of using 2 locking clasp latches. I found these on Amazon, sold by a company named Uxel. The original intent was for use on a toolbox. The part number for the latches is Uxel A1510200UX0346 Toolbox Case Toggle Locking Clasp Latch. These work extremely well for holding the 2 panels together. I also installed handles to make it easier to carry the panels when transporting them. Now, let's head outside to take a look at the system in operation. I'm going to change microphones, so don't be surprised if I sound a little different. This is the solar power system in operation. The 2 solar panels are connected to the power control board using a pair of Anderson power pole connectors. I used the 10 AWG power leads that came with the Renogy solar panels. This allows me to position the panels up to 20 feet away from the power control board. The battery is a standard deep cycle lead acid 12-volt battery. It is connected to the charge controller, the MFJ battery booster, and the Pure Sine inverter. The overall performance of the system is displayed on the Bayrite LCD digital panel meter. This displays the voltage being generated by the solar panels, the amount of charge current in amps going to the deep cycle battery, the overall power in watts being produced by the solar panels, and the total energy generated in watt-hours. These are the solar panels that are just set up against the side of the house. As you can see, they're in the shade right now, but yet they're still generating 12.18 volts at 170 milliamps, providing 2.3 watts on charge current into the lead-acid battery. I hope you have enjoyed this video and will subscribe to my channel. Also, check out my page at Patreon at patreon.com/technog if you would like to help support my channel. This is Bill the Techno Gypsy saying 7-3 and God bless.